Welcome to 8.4 trigonometric substitution, or inverse trigonometric substitutions, or as most of us just call them trig subs. Alright, so I'm going to give you a table, and maybe it makes some sense to you, maybe it doesn't. I don't know. We'll see. So, we are dealing with things that they're not going to start with trig. We're going to turn it into trig. I know that probably goes against everything that's in you. Like, what? I'm going to change polynomials into trig? Yes. So we have, if you ever have an a squared minus an x squared, we could actually call x just a times sine. So then when you go and replace it in for x, you get your a squared sine squared, and you can factor out an a squared, and you get a squared times 1 minus sine squared, which is identically equal to a squared cosine squared. And you're like, huh? What? What? Let's see it. Let's go. Oh, so this is the scenario we came up with. Right inside of here, we have the square root of 3 squared minus x squared. So we're going to do these things a little different. We've done u subs before, but not quite like this. We're actually subbing in a backwards way. So this is what we need to do. So that's going to be our sub. We're going to say, let's let x equal 3 times sine of theta. We're going to change them into angles, and we'll deal with it there. If your trig wasn't good before, you're going to have no choice at this point. Now, just like we did with u subs, we need to take a derivative, dx. But for us, there's the dx. We're just going to replace it with whatever our derivative is. And it's 3 cosines of theta d theta. Okay, let's go. So let's sub it in. Let's see what we get. So we have the square root of 9 minus something squared all over something squared. So let's go through and replace with our x. Our x is 3 sine of theta. Now we need to replace our dx, which is going to be 3 cosines of theta d theta. Like, everything looked fine before. Well, yeah, good luck. Go back through that and try and do a u sub. Try and do that by parts. Tell me how it works out for you. This is the way we need to get through it. So let's clean stuff up just a little bit. So we have the integral of the square root of 9 minus 9 sine squareds of theta all over 9 sine squareds of theta. And we got this 3 cosine. I'm going to take the 3 out to the front and then just leave our cosine of theta right here. All right. Now, once we get better, we'll start to see that this is just going to pop out a 3. But let's take it step by step just to begin with. So this is the square root of 9 times 1 minus sine squared of theta all over 9 sine squareds of theta times cosine of theta d theta. Maybe just leave it like that. The multiplication. And we all know 1 minus sine squared, don't we? Come on, man. You know this, don't you? So the square root of 9 is 3. Well, hold on. Let me go step by step. Let's make sure that we do this the long way. 9 times cosine squared of theta all over 9 sine squareds of theta times cosine of theta d theta. Now we can take the square root of cosine squared and call it cosine, but that's only true, right? Cosine can be negative. This is only true for theta in between negative pi over 2 and pi over 2. That's where cosine's positive, by the way. That's where cosine's positive. And we're going to have some more rules popping into this in a second. These are all long problems. So what we can say is this is equal to 3 times the integral of 3 cosines of theta over 9 sine squareds of theta times cosine of theta d theta. Well, 3 times 3 is 9, and 9 divided by 9 is, well, 9. So what are we left with? This is cosine squared of theta over sine squared of theta d theta, which is identically equal to cotangent squared of theta d theta. What the heck do we do with that? We use an identity. Did you know that cotangent squared of theta is equal to cosecant squared of theta minus 1? Did you know that? Did you know that cosecant squared of theta is equal to cotangent squared of theta plus 1? It's all coming from those Pythagorean identities, so we can replace that because we know the antiderivative of cosecant squared. We do, I promise. So, what do we got? Nope, I got this backwards. Hold on. I made a mistake. Hold on. I always make this mistake. Hold on. Sine squared of theta plus cosine squared of theta is equal to 1. I get my signs backwards, and I want to create a cotangent. So, that would be, there it is. We just divide by sine squared everywhere. I'm sorry, sometimes I forget these formulas. Okay, so cotangent squared of theta is equal to cosecant squared of theta minus 1. Okay, there it is. I got it backwards. I got my numbers all screwy. So this is the same thing as cosecant squared of theta minus 1 d theta. We can handle this though, can't we? This is just going to become negative cotangent of theta minus theta plus c. And we're like, yay, we're done. We did it. No, we're not. This problem started in terms of x's. It needs to end in terms of x's. So here is our game. We need to go back to our original substitution. Now, let's divide out the 3. Okay. Well, let's look at this. Let's figure out what our angle is. Now, if we hit this with an inverse on both sides, we find out that theta is equal to inverse sine of x over 3. And once again, theta can only be in between negative pi over 2 and pi over 2. So without loss of generality, I'm just going to draw our triangle in the first quadrant. No big deal. Now we're all familiar with the idea that sine is the opposite over the hypotenuse, so we get 3 and an x. And now we have to solve for this adjacent side. I'm going to call it a for just a second, and we say that a squared plus x squared is equal to 3 squared. And we want to solve for a, so a squared is equal to 9 minus x squared. I swear I've seen that somewhere. That's not a coincidence. And that a is equal to the square root of 9 minus x squared. And I don't need a plus or a minus because look where a is. If it's in the first or the fourth quadrant, it's always going to be positive. All right. So what's cotangent? Well, let me take this back down to the beginning. I know these are long problems. Let's take this down to the bottom. Just a little bit bigger. Oh, and I forgot to write something in there. There's theta. And do you remember what theta was equal to? Theta was equal to inverse sine of x over 3. because we need to replace our theta, and we have to replace our negative cotangent of theta. So what's cotangent? Isn't cotangent? Cotangent is our adjacent over our opposite. So we're going to get the square root of 9 minus x squared over x. Now we need to replace in for our theta, and our theta is equal to inverse sine of x over 3, all plus c. How you like that? 10 minutes to do one of the simpler problems. This is, well, it's actually not that. There's tougher, there's simpler ones than this. Oh my goodness. So I guess we're going to do like a problem at a time. We'll just do ourselves a problem at a time and see what's going on. All right. See you in the next.